Hi, good day to everyone. Welcome to our webinar on how to build edge AI and computer vision proof of concepts in 4 weeks with ready to deploy hardware and tunable algorithms. Today we have three presenters. Myself, Maharajan Veerabahu, co-founder of Econ Systems. We also have Mr. Gomati Shankar, who's a product manager in the OEM camera group of Econ Systems. And we have Mr. Sharath Natakam, head of engineering of Visai Labs. Most of you have seen AI and computer vision demos. Many of them are hogging your social media timelines. But we have faced a lot of customers and we have seen a lot of people come to us asking, how do I take AI or a computer vision solution to market? How do I apply this edge AI or a computer vision concept in a real life use case? So this webinar is an attempt to answer some of those questions. And this webinar is our experience of how we have approached to solving this problem. So let's go ahead and have a look at the agenda for today's webinar. So what are we trying to cover here? See, the first thing that we would go about is to see a step-by-step plan on how we approach a proof of concept. So any idea or any solution that you are designing, we would require a proof of concept to prove that there is technical feasibility in it. And in some cases, a business viability will also need to be checked. So that's the reason why we go for a proof of concept when we talk about a solution. And that is more true when we are working on cutting edge technology and latest algorithms. So the first thing we will see is how we approach a proof of concept. And then after that, we would see what hardware that we choose. Because when it comes to edge AI, the hardware that we choose plays a very vital role. And the hardware consists of both the CPU, the camera, and so on and so forth. So we'll be going in detail about how we go about choosing these pieces of hardware to make our proof of concept. And of course, the most important part of the proof of concept is the algorithm. We'll also see how we can take up ready-to-use algorithms and how we can build this proof of concept and what kind of expertise you will require to do the POC. So this is in short the agenda for today's webinar. And I'll go about, first we'll introduce who we are, and we'll also tell you about some of the use cases that we have worked on. So we Econ Systems have two divisions. One is the OEM camera group. So we deal with OEM camera products, and we have been selling our camera products which are inside other customer products. So we have over 300 products in the market with Econ Systems camera modules in them. And we have developed over 45 camera products and development kits that we sell through our website. So that is the background of Econ Systems, and we have been in business for the past 18 years as a camera company. And there is a division within Econ Systems called Visai Labs, which is focused on vision and AI. And here we work on all the AI algorithms and models. And many of these proof of concepts were developed with Visai Labs algorithms. So I'll go forward and I will explain how we go about doing the POCs. So when I talk about the proof of concept, I think the best way to explain a solution is to take some examples. So we have taken some case studies here, which we have worked on, and probably I would take one case study and I'll explain how we can do a 4-week POC with that case study. That's the approach we are taking today. So in the case studies, we have done a smart cart, an automated checkout, both that works in a retail store, a smart surveillance solution, which has been used in office spaces, and then a smart digital signage, which actually captures how people are interacting with it. So this is a short video that shows some of the proof of concept demos. This video would have given you an idea of what we mean by a proof of concept. So most of the demos or the demo videos that you saw are proof of concepts, and they were built in 4 weeks time. Now I'll walk you through how we approach this 4 weeks. So the week 0, which is the first week, we focus on discussing the requirements and identifying key requirements that need a proof of concept. So what is the difference? So we talk requirements in general, but we have to be more specific on key requirements. Sometimes the key requirements are what kind of objects we are going to detect, or what kind of environment we are going to use this solution in, right? And in some cases, the key requirements are performance metrics. We may want an accuracy of more than 90%, and without which the solution might not work. So we have to identify or pick key requirements in a whole list of requirements, and we'll decide on what we are going to focus in a proof of concept. And the exploration phase, which is the week 0, we also have to decide on the computing hardware. So here, decisions like whether the solution is going to be an edge-based solution, and whether it's going to be a cloud-based solution. So if it is an edge-based solution, what is the need for it? And what is the processing power that is required for the algorithm at the edge level? What is the cost that we are targeting for this solution, so on and so forth. So we need to make a decision on what type of computing hardware we are going to choose, and also a choice of camera. So what are the lighting conditions? There are so many conditions, and there are so many points to consider when we choose a camera, and Gomati Shankar will explain this as we go forward in this webinar. So in the first week, it's all about understanding what requirements we are targeting. We're just basically setting the goalpost and the expectations for our proof of concept. And also, we are trying to pick and choose the right hardware, both in terms of the CPU as well as the cameras in the first week. Going on to the next week, it's going to be about the POC setup. So how do we make a POC setup is we normally pick hardware which is off the shelf. So we do not want to develop an entire hardware during a proof of concept stage. So we want to pick up an hardware which is off the shelf, targeting some particular development kit along with the camera, and then taking it out. And likewise, we also have to pick up an algorithm which is already available. Of course, there are options in the open source where you can pick up a model and you can try and use that. If you're already experienced with AI and machine learning and deep learning, if you're experienced with that, then you can pick up something from the open source. Or there are a lot of third-party vendors like Visai Labs who have these algorithms readily available, which you can pick up and you can use it to set up your POC. Now, at least a week, it takes at least a week to get all this up and running. So you have some working setup. You connect all this and make some basic application, which will target the solution. Now, the third week is all about tuning the algorithm. Now, I have connected all the pieces together. You have the camera images flowing through your algorithm, and there is an inference happening, and there are some decisions which are being made. And now it is about tuning your algorithm. And in some cases, we go ahead and retrain the model to include new objects and things like that to achieve the level of performance that we want. So that happens in the week 3. And the fourth week is about putting everything together and showing it to a customer or showing a demo to him. Now, all this may sound very simple and like bifurcating into weeks, but in practical life, I mean, most of you are developers and engineers, you know, it does not go exactly to plan, right? So sometimes what we have planned in week 1 may happen in a couple of days, but we may take more time where we are spending in tuning the algorithm. So we'll take a week or a week and a half. But our experience is that in most cases, we have been able to come to a proof of concept demo in 4 weeks. That has been our experience. And this is a rough split on how you can split your, if you're planning for something like this is how you can plan. And from week 4, it is about deploying it in the customer's test zone. So normally you make a POC because you wanted to deploy it somewhere and you want to check. So there are 2 things which I told you first. Either it is technical feasibility or business viability, whether this model will work, right? So both of these have some target numbers which you can start experimenting from week 4. In the POCs that we have worked with, we have worked with customers for a couple of weeks in some cases, and with some customers we have worked even a couple of months because the experiment took long. We needed more data, so we got a lot of real-time feedback. And we've also then working on a second stage of a POC where we go ahead and optimize even further. And this is how we come to a final solution from a POC to a solution. One thing we all must remember when we are working on a proof of concept is this is not just a demo. It is not a video that you can capture and put it in your social media handle and walk out. Because this POC is going to be the building block that is going to bring about your solution at the end. So whatever we use here should be a viable and we should be able to build on top of this and go towards our final solution. So that should always be in our mind when we build this POC. And that's how we have worked with our examples as well. Now, I've told you how this 4-week breakdown happens and what all we do in that, what may take more time and what may take less time. Now, going forward, let me give you a case study, an example of how I apply this 4-week to that case study. So this case study came to us from a customer who wanted help with a self-billing solution in a supermarket. Of course, this is a very common use case. We have heard this a lot from a lot of different people. So the customer who came to us had two kind of requirements. One is they wanted to identify fruits and vegetables in a shopping cart. They would take up the fruits and vegetables in a bag and put them in the cart. And they had a camera. They wanted a camera system or a vision system in the cart, which would actually look at those vegetables and fruits and give the name as well as the cost, and maybe if there is an offer or whatever, it should show it on the card. So that was the final requirement basically. But the proof of concept was all about identifying the fruits and vegetables. Now the second requirement they had was the same fruit and vegetable identification in addition to grocery identification at the counter. Now these fruits and vegetables have different codes and they have different names. Like there are 2 or 3 types of apples all with different names. So the checkout person, when he showed a bag, he wanted the vision system should spell out the name of what type of apple it is and also give you the code for it. So this was a requirement the customer had. And now here they had both the questions. They also had the question of technical viability. Of course, there was no requirement to have 100% accuracy with this. There was no requirement for that, but they prefer to have at least 80 to 90% of accuracy with this solution. So they wanted to know how technically feasible it is. The second thing they wanted to understand was the business viability. Now, how will shoppers react if I put such a vision system in the shopping cart? And how will the clerks at the counter, how will they react and how will their work get more easier if such a helpful vision system is there on the counter? So this is some experiment that they wanted to do. And we took this up as a proof of concept to show them how we can deploy it in 4 to 5 weeks in their premises. The basic challenges that we took were that we have to identify fruits and vegetables. And we said that we will take around 20 different fruits and vegetables, and that's the first set that we'll be working on in this POC. So this is what I call by fixing your goalpost. So we will not say that we'll do all fruits and vegetables, but we'll pick them and we'll build a POC only for that. The next thing we decided was that they wanted to train a new fruit or they wanted to train a new grocery item at the store itself, which means that we needed to include a training module. Of course, that will not run on the edge itself. The training could run on a PC or on a server, but it could be deployed back on the edge device, and you should be able to infer the new fruit or the new grocery item. So there were 2 main requirements that we took. One is identification, and the other one was training a new item. So these were the 2 requirements that we took, and we went forward with this proof of concept. So Like I said, in the exploration phase, the first part of fixing the requirement and fixing the goalpost was done. So here we've identified a lot of challenges, right? There are a lot of occlusions that come because we put these fruits and vegetables in a bag. The lighting conditions might differ. So those were some of the possibility for these occlusions. And then, like I said, when we have apples, a lot of apple varieties look very similar. We need to differentiate as well. So in our requirement set, we took at least two apple types of apple so that we could differentiate between those types. So that was part of our fixing the requirement. And also we worked on certain lighting conditions, 2 or 3 lighting conditions we fixed so that we could check the accuracy at those lighting conditions. Our intention here is not to fine tune for everything and reach our final goal for the solution in this 4 weeks. What we need to prove in a proof of concept stage is to say that there is scope for improvement. Like if we are able to achieve something, if we are able to demonstrate some solution, and then if we are able to prove there is scope for improvement, then we will call this POC as a success. And then we can go ahead developing this as a full-fledged product or a full-fledged solution, right? So we identified the key requirements for the POC and we move forward in making the decisions for the computing hardware. So here what we are going to do is we are going to run an algorithm. We already had an algorithm which we have used for similar purposes, and we found the NVIDIA Jetson hardware as a good fit because it has the necessary GPU and the horsepower to run these inference engines on the edge. And of course, we have a lot of cameras which we have already worked on, which are connected to the NVIDIA Jetson platform as well. So we thought that was a good starting point. And the choice of camera, also we wanted to have a camera which will work under normal lighting conditions and also which had some good depth of focus, because we assumed that it is not always the fruits or the vegetables, they're not always going to be at a fixed distance from the camera. The height would differ. And so having a camera with a good depth of focus will give us a very clear image of the fruits and vegetables. Of course, we needed proper color reproduction because a lot of that would depend on the color of these fruits and vegetables. So we needed a good quality camera which worked under normal lighting conditions and a good depth of focus. So this was what we identified in the first exploration phase. And from there, we went ahead and decided on the exact hardware in week 1, where we finalized on the photon carrier board. We took that off-the-shelf NVIDIA dev kit, along with one of Econ's cameras like Ecam 50 CUNX, which is a 5 megapixel camera, which we attached to the NVIDIA dev kit. So because this is a ready-to-use development kit, this has the camera running on it already. You have all the software which runs on this dev kit already, and you could get the camera streams to memory with an application straightforward. So the next step was to pick up an algorithm from our Visay platform. So we used the algo accelerator, the object detection algo accelerator from Visay platform, and we put that into this dev kit as well. So this is all like picking pieces, like we are picking pieces of building blocks which we are aligning one after the other to build our solution. And that's what we did with week 1. And the week 2 is all about putting this into action. So we bought samples of all these fruits and vegetables which we targeted, and then we retrained the model object detection algorithm block. We retrained that to include these fruits and vegetables, and we went ahead building our application for this as well. And once the training was complete, we built a basic demo application for anybody to use with a touch-based interface. I mean, this is like a basic sample application. Nothing very fancy. It's just a straightforward application which will do detection as well as it could also do training with a click of a button. Once all this was done, we did a demonstration to our customer at week 3. So here, the confidence of the customer, like when we started with week 0, when we started with defining these requirements, to having something working on week 4, we had built the confidence on the technology part at least. So the next part went to putting this on the store and checking the business feasibility, which the customer did. So basically, The outcome for the supermarket was they were able to see the pros and cons of this idea, both at the business level and at the retraining level. Of course, this POC, when it is actually put on and when it is being tested, this has to be treated like a POC. So it is going to have problems. It was not like all perfect. It was not like the 100% perfect solution, but it met all the requirements. So when we were able to get accuracy of around 70%, 75% at some instances, we were sure like with more training and more fine tuning, we will be able to reach the 85 to 90% which the customer wanted. So just like I said, it was able to meet our requirement to a certain extent, and there was scope for improvement, which is all we wanted from the POC. So that's about how we approached this proof of concept, and how we went about giving this proof of concept to a customer and how he used it. And one of the main reasons he came to us was because all of these were already in some shape available to us. We had the dev kits and we had the algorithms. And this is this when you approach a POC as well, if you have ready-made dev kits, that, or if you are able to pick ready-made dev kits from the web, I think that would be a very good starting point. And also some algorithms which are off the shelf, be it open source, which is freely available, or some algorithms from companies like Visai Labs, where you can pick and try and use them so that you can quickly figure out whether your thought process or your idea will work or not. Now, coming into building a POC, there are a lot of things that you will have to think about when you start a proof of concept. When I say you can do this in 4 weeks, we have to understand that there is a level of expertise that you will require if you have to get this done in this short period of time. And it is not only expertise, I would say it is some familiarity with these kits. Now, you can identify off-the-shelf hardware kits. When you identify off-the-shelf hardware kits, it cut down your cost of building your own hardware. That is perfect. You can find off-the-shelf algorithms, and now it cut down your cost in building your own algorithms. That's perfect too. But when you want to put all these together, you would require some kind of expertise or some familiarity with these things. If you are familiar with this, then this 4 weeks time frame works like a charm. There's no problem with it. Otherwise, there would obviously be time required for you to get familiar with all these tools, to get familiar with all these platforms, right? So that is something that you need to think about when you're starting a POC. And for the success of any proof of concept, when it is connected to AI and edge, I think there are only 3 areas that we need to focus. One is the camera, because that is the core for your vision system. So you need to understand which camera is the best suit for this use case. Because the best, if you can get the best image, if you can get the right image to your model or your algorithm, then you amplify your chance of success, or you amplify the chance of making your algorithm work like incredibly. Whereas if you choose the wrong camera or a wrong lighting or wrong lens, then of course, however good your algorithm might be, it would not give you the right output or the solution. So choosing a camera is very important. And I think we'll go forward and we'll see how you can choose your camera. Gomati would explain more on that. So the next thing is choosing an edge processor. Again, the edge processor, like the camera, you need to understand the horsepower that's behind this edge processor. Has this algorithm that you're picking off the shelf, has this been tested on this platform? Because if it has not been, then you carry the risk of trying new on this hardware, and that is going to consume a lot of time. So when you pick an algorithm, you have to make sure, and when you pick an edge processor, you have to make sure that it has been tried before. If it has been tried, then it's well and good. So choosing of the edge processor is going to be a very critical part, and that will be covered in the webinar going forward as well. And last but not the least, the algorithm block. And like I said, you pick an algorithm which has been already tested in these processes, and also understand what has been already done with those algorithms. What is the performance output of that? What kind of training it has gone through? What model or what kind of data set was used to train these algorithms? If you can get as much information as possible, it's well and good. And otherwise, it is better to have some algorithm vendor who is experienced with that to help you with this part. So these are the three main areas where you need to focus when you do a POC. And the rest of this webinar, our team, Gomati, and then followed by Sharath, they will be focusing on how you have to choose this and more technical details on these three areas. So thank you, one and all. I'll pass this on to Gomati so that he can carry on with the next part.
Thank you, Maha. So as Maha rightly said, if you get the right image at the right time, that makes the POC, probability of the POC successful. So if you could imagine the final product and choose the right hardware components for it, probability of making a successful POC is very high. Choosing the right interface for the vision system, right image sensor, and image signal processor for this sensor are the key challenges. So we should understand the ability of the sensor for a particular application. So let's start looking at the sensor. Due to the influence of cell phone cameras, high resolution might always be the first thing we will look at. But there are several other things to consider. Each application has its own unique set of problems that can be addressed by a particular sensor. Let's assume an outdoor kiosk. The major problem with the outdoor kiosk is the lighting condition. The lighting condition is going to be harsh. Sunlight might whitewash the complete image. You might also get into both bright light and dark light on the same scene. So getting the sharp images for a facial recognition or similar application is going to be really tough. So if you choose a high dynamic range sensor, that could really help in this situation. A HDR sensor can actually capture images with two different exposure and measure together to get the right mix. So I would recommend to consider the following things before choosing the sensor. Of course, the first thing is going to be the lighting condition, whether it is a low light condition or a controlled room light condition or an outdoor lighting condition. Whether the target is going to be stationary or moving. Going to capture still image or video for the recording. If it is the video, what is the frame rate and resolution requirement? Field of view of the lens and focus method, whether it's an autofocus or fixed focus. These are the things you should consider before choosing the camera module. Also, if the use case requires a color camera, make sure to choose the camera module with image signal processor. The image signal processor is the one which is responsible for auto functions. Adapting to different lighting and perfect like color reproduction is a key thing, and without an image signal processor, it is going to be really tough. So consider these points before choosing the camera module. Another major thing is the interface for the camera. So these are the four major interfaces we used to see it with HCI devices. Okay, so MIPI CSA2, USB 3.0, GMSL, Jiggy. Let's understand the pros and cons of the camera interface before selecting it. MIPI CSA2, of course, is the most reliable camera interface for HCI. Also supports very high bandwidth. And the quality, we can get raw images for it. So since it's a raw image, there is no processor bandwidth will be used for this camera. But the limitation here is the range. We cannot go beyond 50 to 100 centimeter with MIPI cameras. USB, we can go for longer cable, of course, but it has also a limitation of bandwidth. But USB has a fair enough bandwidth for full HD 60 frames per second. So if you are looking for a POC with a decent camera, then probably USB 3.0 for the POC would be a better choice compared to other interfaces. It has a reliability, it has a decent reliability, it can also support high bandwidth, and you can go for 3 meters or 5 meters. Also, it can support both OUV and MJPEG. Jiki is the next one on the list. If you are looking for a longer cable length, then Jiki would be the best choice. It can go for several meters, but the thing is, it cannot support higher bandwidth. Always the Jiki cameras will provide a H.264 encoder stream, so the quality may not be good enough for the application. GMSL is a SerDes method for transferring MIPI data over the longer cable. So these are the cameras I would recommend for the smart shopping cart, digital signage, and smart ATMs. As I said, for the outdoor condition, I would recommend HDR camera, full HD HDR camera. So we have this full HD HDR camera in both MIPI and USB interface. And the next thing is the facial recognition application. So if you are just looking for facial recognition, not going to do the spoof detection, then probably a 2D camera will be fine. But if you need to do spoof detection, like presentation attack detection, then you might need a 3D camera, which will give you both a 2D image and also depth information to check whether it is actually a real person or a photo or a video. Let's assume you want to capture images in a shopping cart. If you want to capture it while it is in the moment, you would need a global shutter camera. A rolling shutter camera will create rolling shutter artifacts that might create problems for your algorithm to detect the objects rightly. It could be like a fruit, or it could be a barcode. In both cases, if it is a moving object, global shutter would be a better choice. Then the high resolution camera. Imagine a situation, a digital signage or a kiosk. If the person is standing 2-3 feet away from the kiosk or a signage, the resolution of the face alone is going to be really low. The high resolution camera along with an autofocus functionality will be really helpful. As I mentioned already, all these cameras are available in both USB and MIPI interface. So here comes the major component, the processor platform for AI/ML. As Maha said earlier, you have to choose the processor based on the horsepower required for this particular algorithm. And also it has to fit into your budget. So if you choose a processor, low-cost processor, which has the decent ability to run basic things on the processor, and you can do the rest of things on the cloud. So these are the most popular processor platforms that are available for cloud-based AI. So these things, you can run some basic algorithms on these processors, but you cannot, you don't really have a dedicated GPU or a TPU or any AI/ML engine running on this. So you may not be able to run a full-fledged edge AI algorithm here. So you can use these platforms for grabbing the images, encode it, and send it across a network for a cloud AI. You can, as I said, you can do the basic stuff, but majority of the things should be done on the cloud AI. Also, you can include an Intel Movidia stick to these platforms. That will make this as make you to use this for HA processing as well. The first one is the Raspberry Pi. That's a quad-core processor available in both SOM and single board computer. The most popular low-cost edge device. Rockchip, another low-cost quad-core processor, and the NXP-based IMX6, IMX8 processors available in various processor combination, again good enough for low-end edge processing. And these are off the shelf; they are ready to deploy as well. These are the most popular edge device. Okay, so you have special cores here for running your algorithm on the edge itself. The first one is Google Coral. It is actually based on NXP IMX8 processor, but it comes with a Tensor Core chip, which can be used for both edge AI processing. Google provides a SOM. This SOM is still in the early stage. We are supporting MIPI cameras for it already. The next one is Qualcomm QCS. It is different from Snapdragon processor. It is specifically designed for edge AI. It has a dedicated AI engine along with the processor. As I said, these three processors family has its own engine for AI. Also has an option to connect multiple cameras. So if you are looking for interfacing multiple cameras, probably the Qualcomm and the NVIDIA are the most preferable one, because NVIDIA Jetson processors can have up to 6 cameras, and the 6 cameras can stream Full HD 30 frames per second. Qualcomm also can support multiple cameras. So if your application is going to have multiple cameras, you might need to consider Qualcomm or NVIDIA processor. As I said, the NVIDIA is the next one. NVIDIA has a wide range of processor, right from Nano to all the way up to AGX Xavier. Nano is the most cost-effective, low-end edge AI processor, and AGX is a high-end edge AI processor. So Google calls it as TPU, Qualcomm calls it as AI engine, NVIDIA calls it as GPU, but all of them has the ability to run a full-fledged edge AI on the edge. Okay, I'm giving over to Sharath, who will take you through the algorithm part.
Thank you, Gomathi, for detailing us on the cameras and platforms for AI solutions. Good morning and good afternoon to everyone. Let me reiterate what Maha said. To build an AI solution, we need a camera, an edge AI hardware platform, and an algorithm. So in this section, I'll be explaining the details of AI algorithm development. So in an AI algorithm development, there are multiple steps. So that includes from data set preparation, AI model development, training, accuracy analysis, performance tuning, and deployment. So in case of dataset preparation, which is very crucial for any AI solution development, because the dataset is key for achieving better results in any AI application or a solution. So a dataset needs to be collected from a particular customer, or in case of freely available datasets, the dataset need to be cleaned up. It needs to be annotated, and it needs to be separated as a training set or a test set. And in case of limited data, we do something called as data augmentation, where we try to multiply the given set of data by introducing different lighting effects, orientation. We also introduce some form of blurring, etc., to match real world use cases. So for any AI solution, dataset is the key, and that needs to be prepared before you do anything in an AI solution development. So the second step is AI model development, where we generally try to figure out if there are any standard models, or if one doesn't exist, we build it from ground up. So in case of AI model development, we generally work on customizing 5 to 10 layers of a given model. And we also try to figure out a loss function, which is very critical in case of model development, where a model is trained, and we figure out if the model has a required amount of accuracy, and we try to tune the model based on the learning and the loss function. So we also employ techniques such as non-maximal suppression in case of detection models, where we get duplicate detections. So these are part of AI model development. So once we do dataset collection and we do our model development, the AI model needs to be trained. So for training, we employ the data set which we would have prepared in step 1, and we do our training either on multi-core system in-house, or we use cloud systems for training the model. So we constantly monitor the training process to see if the model is learning, if it has stopped learning or reached a stage where there is no considerable learning, the training process is concluded. And we go to the next step, which is accuracy analysis. So in accuracy analysis, we take the test set and we feed it to this trained model, and we understand the output from the model to check if it has reached a set of accuracy metrics. So in case of object recognition models, so we have uh, metrics such as MAP, mean average precision, uh, and in case of classification models, we try to employ metrics such as top 1 or top 5 to see if a model is performing to the level of accuracy that is required for a particular use case. So post accuracy analysis, we do something called as performance tuning, because by this time you would have taken a model, you would have trained it, and you would have checked the accuracy. Now this has to run on an edge AI platform, which has very limited resources compared to your cloud, or on a CPU with a big graphics card, or for that matter any AI card on a bigger PC. So we take this model and we try to deploy it for your specific hardware which is chosen for a given use case. So when we deploy our model for an edge processor, what generally happens is uh, the performance drops. The reason is these models are generally heavier to run on a small device such as an NVIDIA Nano or a TX2 or a Xavier from, let's say, from NVIDIA. So what we do is we employ techniques such as pruning, where we figure out, okay, if there are like 50 layers, some of the layers are not contributing enough to make a decision. So we try to cut down those layers, and we try to save the cycles that are required to do a particular process. So one such technique is pruning, and we also try to analyze the precision versus accuracy. Suppose we employ a floating point 32 in our particular inferencing engine, we try to see if a floating point 16 is good enough to meet the same accuracy, so that the processing can happen faster. So we employ some techniques, a few techniques such as these in our performance tuning stage. Once the performance tuning is done, we go for deployment. So this particular slide talks about various platforms that are available to you when you do AI solution development. So the first one is Visay platform. This is a platform which we have developed with over 3 years of R&D at Visay Labs. Visay platform comes with pre-trained and customizable models and tools, which one can take and create solutions for use cases such as smart checkout, smart digital signage, and smart surveillance. So the models can be easily ported with very minimal effort on most popular edge AI platforms that are available in market today. The platform is also easily scalable and deployable to production systems. So one can easily evaluate our platform by taking our evaluation version and using it for a particular use case. So the next framework is NVIDIA DeepStream. So NVIDIA DeepStream is developed by NVIDIA and comes with pre-trained models. And the most popular one is PeopleNet, which is used for people detection. And NVIDIA has recently released a transfer learning toolkit using which a pre-trained model can be further trained for a particular use case and can be deployed for a particular use case. And the next framework is OpenVINO, which is developed by Intel, but it doesn't come with a transfer learning toolkit. Again, OpenVINO comes with standard models for specific use cases, which one can use and develop their prototypes. And the last one on this slide is TensorFlow Lite. It is a go-to framework for edge AI development, especially in case of Android GPUs such as Mali. And companies like Qualcomm, they provide TensorFlow Lite optimization tools for their chipsets. This particular slide talks about our solution for smart card. So a smart card solution involves developing an object detection and classification models. So the right side of the slide talks about various data sets that are freely available in the market, which one can pick up and try to train their models when developing a smart card application. So generally a smart card application will involve thousands to lakhs of different objects that need to be detected and classified. So in a retail space, so things can vary somewhere from fruits, vegetables to goods that are used by retail customers. So if you try to train all this using a single model, generally it takes a performance hit, especially on an edge hardware. So how VC Labs has solved this problem is by using a model hierarchy. So what we have done is we have used a class and subclass hierarchy where a main class will classify something as a fruit and hand over it to a subclass which will actually recognize it as an apple or a banana. So this is an innovation we did to solve the performance problem for the smart card application. So this particular slide explains about the digital signage application we developed. So in case of digital signage application, we had to develop three different models to address face detection, age and gender prediction, and gaze estimation. So this particular slide is listing the different data sets that are available on the internet. And a smart digital signage application needs privacy because this is placed in public and customers do not prefer to have their images on the system for privacy reasons. So what we have developed is called as anonymous video analytics, where on the edge we read the images from the camera, process the images on the edge and discard them. And all the analytics on these images goes to the cloud, and none of the images are stored on the cloud. So this is a way we ensure the privacy of the customers in the digital smart signage solution. So this involved developing three different models. So for face detection, age and gender prediction, and gaze estimation. So we had to develop all these three models, combine them, and produce the end solution for our customer. So this particular slide talks about a smart surveillance solution, which we have developed for our customer. And as could be seen, most of the data set which we could find on the internet was a non-commercial data set. So we had to develop our own data set, and we had to follow the process called data augmentation. So we had to collect 2000 different images, and we had to perform the data augmentation, which I described as the first step when I started explaining about algorithm development. So we had to develop two models for this particular problem. One is the bounding box model, and the other is the classification model. And we have to deploy this solution using these two models. And that is the end of algorithm development presentation from me. Thank you. Now I hand over the presentation to Mr. Alphonse.
Good day, all. I think you all had a really interesting time trying to understand what is the 4-week POC methodology for building edge AI and computer vision solutions. Now, we were predominantly focusing on explaining to you how this methodology, how we have used this particular methodology to help n number of customers get their edge AI and computer vision applications fast into the market. So some of the other use cases which we built was a smart digital signage, where we helped incorporate AI into the digital signage within 4 weeks. So what did we do? We built together a Raspberry Pi plus an Intel Movidius and a C3CAM CU50 solution, which can identify a person's age, gender, gaze deduction, while also calculating the gaze deduction, dwell deduction, and emotion. How does this actually help the customer? Because streaming almost 4K videos from every single digital signage to the cloud and processing it over there is not viable from the point of bandwidth, and also it intrudes upon customer privacy. But instead of that, if you can get the video and work on it on the edge and just provide the metadata out, you not only do you have better economics, but also safeguard the privacy of your customers. The other is a smart surveillance solution, which is basically an anti-spoofing algorithm, which we built for a smart ATM. We use the VTrax people deduction service along with the Tara 2C 3D stereo camera, which Mr. Gomedi had showcased in a previous slide. We used a hybrid edge cloud deployment, and we interfaced the solution with a bank ATM. Now the question is, all this begs the question, what expertise do you actually require to build this end-to-end solution? And why our enterprises are working with Visai Labs and Econ Systems to incorporate Edge AI into their products? The reason is because Visai Labs and Econ Systems is a one-stop provider for all your edge hardware, algorithm, and software needs. The reason is very simple. Think about this. You as an end client, you're a project manager, and you work with one particular partner for your camera, one particular partner for your edge processor, and one particular partner to get your algorithms going. Now, your camera is getting out the stream of images, right? But somehow or the other, the algorithm is not able to capture these images into its pipeline. What do? You talk to your algorithm guy. The person says, hey, talk to the camera people. I think it's their problem. The camera person says, hey, the images are coming out right. Talk to the processor team. So it goes around and around. But if you have a single partner who has expertise across all these three spaces, you just have one person who will be answerable to you and will get the product into your hand. And there are very few people on this planet who can claim to have experience in both camera, who build their own camera while having the partnerships with all major edge processor firms, whilst also having capability across all major machine learning algorithms, as well as having their own edge optimized algorithms in their own platform. So simply put, the two major reasons why enterprises reach out to Visai Labs is that they want to incorporate AI and computer vision into their existing product or solution, like how we saw in digital signage. Or you can check out the smart surveillance solution, which was a new product created from scratch, taking advantage of the best computer vision can offer. So in the maximum reasons, of course, this in the end is to explain to you guys, if you're thinking of building an edge AI solution or a computer vision solution, why are enterprises choosing Visai Labs in computer vision and Econ Systems is because we have expertise in both edge and cloud. We have the ability to provide both hardware and software, ability to accelerate your product development using our own IP, which is this AI platform, as well as our own product development methodology, ability to provide a solution from product ideation to prototype manufacturing. We help you do product ideation, we help you build the POC, we help you choose the camera, we help you choose the processor, we help you build the algorithm and optimize the algorithm, scale the product to production ready solution, and also do the prototype manufacturing. And most importantly, we are not a jack of all trades within Edge AI, but we have focused capability on certain industry verticals and specific use cases. For example, the major industries we work in include retail, logistics and supply chain, and industrial. While the major use cases where we have worked on are people, vehicle detection and tracking, object quality deduction, and object dimensioning. So quality inspection, people deduction, face deduction all come right up our alleyway. Now, gentlemen, this brings us to the end of the presentation. Now we are into Q&A. We have a set of almost 7 to 8 questions, which I think Sharad and Gomati will start answering. Gomati, I think we have already picked up the camera and processor questions for you. The first question is, the question for you is, they want to interface two high resolution global shutter cameras. Is it possible, and how do we do this?
Yeah, it is possible. It depends on the host processor we are going to use. If we are going to use a PC, then we can use the global shutter camera. So for example, we have C3 Cam 20 CUG or C3 Cam 24 CUG. These are global shutter cameras. Both are full HD color, and one is color, another one is monochrome. So you can use USB cameras connected over the PC over the USB 3.0 or 2.0 interface, and there is a special connector on top of these camera modules that can be used for triggering these two cameras in case if you want to synchronize these two cameras. In case of MIPI, first thing, you may have to choose a processor board which can support two MIPI interface. Assume you're going to use an NVIDIA processor that has a multiple MIPI camera interface, and we can have trigger from the processor board. We can have a kind of PWM circuit that can generate 30 Hz or 60 Hz that can provide synchronization for these cameras.
Okay. Thank you, Gomati. Sharad, a question for you. How do you identify pilferage of products from supermarkets? I mean, we have done many projects for supermarkets, right? Especially building POCs and production-ready products. So how do you identify pilferage of products using computer vision?
Sure, Alphonse. Mainly for this particular use case, we need to use something called as 3D convolution layer models. So one such model is C3D, which can generally run on Xavier, and one another thing could be R2D. These are the two things that comes to my mind when we try to build solutions like this.
Right, thank you, Sharad. Gomati, another question just come up for you is, what industrial cameras are available? Is there a custom housing and enclosure? And yes, and what is a maximum FPS for mission type of use cases? So this is 3 different questions in one.
Yeah. So let me take the first one. What are the industrial cameras we have? Maybe we can answer that over the email personally to you. We have several cameras based on for rolling shutter, global shutter, on semi sensors, omnivision. So we have several options there. So in case if you want to go with the global shutter cameras, I would recommend, as I said, 24 CUG. That would be a latest release from us. And also we have IP67 rated enclosed camera that comes with the GMSL interface, perfectly fit for an industrial use case. And we provide enclosures. We provide enclosures for the USB cameras and also for the GMSL cameras. The maximum FPS, one of the global shutter cameras that can support full HD at 120 frames per second, And the latest launch from our side is a 4K camera, which can support 4K at 90 frames per second. Those are the high frame rate cameras we have.
Thank you, Gomati. So one of the other questions which we have was, are you selling AI algorithm package? Yes, we are. We have a this AI platform, which is a combined edge optimized algorithm package for face, people, and vehicle deduction. We can send you the links uh, in the chat box soon. The second question is, my thought is all the code is running real time on the processor board. Not sure why cloud is involved in this topic. Sharath, could you answer this question?
Sure, Alphonse. So, in case of some deployments where the use case demands larger processing and also optimizing costs, so we try to use an edge plus cloud deployment model. And in case of our own solutions, such as smart card, and digital signage, and smart surveillance, we need a lot of analytics that needs to be run, which we generally run on the cloud. So the number crunching alone, where we do object detection recognition, is done on the edge processing platform, and the rest of the metadata is carried to the cloud, and the analytics is done on the cloud. All kinds of business intelligence and other things are done on the cloud. So that's where we try to use cloud systems in case of edge AI solution development.
All right, thank you, Sharath, for that answer. Gomati, the question for you is, I'm looking for an hardware synchronized multi-camera solution. I use it for agriculture outdoor application, so I would need it to be water resistant and has industry mounting option. Also long cable up to 10 to 20 feet. Any product can meet this requirement.
Sure. So I would recommend StudyCam 20. That's one of the latest launch from our side. It's an IP67 rated camera, so it is immune to both water and dust. And these are GMSL cameras, so we can go have cable length up to 50 feet, not just 10, 20 feet, we can go up to 50 feet. And we can have up to 6 cameras with NVIDIA Jetson Xavier, and we can have 4 cameras with NVIDIA Xavier NX, and all these cameras can be synchronized as well. So I will send you the product link over the email.
Sharath, who will be taking this question? What are some causes for problems with autofocus algorithms on the Jetson Nano?
Not very sure what exactly the autofocus problems that you're facing in Jetson Nano. Maybe if you can come out with more details, I think we will reach out to you over your email and discuss more on this. But specifically, we have not seen any specific.
So it depends on the ISP you are going to use. So autofocus is generally controlled by the image signal processor. Whether you are using the internal NVIDIA Jetson processor ISP or you have an external ISP, and functionality of that depends on the ISP mainly. So you may have to fine tune
the autofocus problem is on a MIPI camera, is the answer from the team. And yeah.
Regardless of the interface, whether the MIPI camera has its own ISP or it is using NVIDIA's ISP, and fine tuning that may require if you face any issues. So ISP fine tuning required for fixing the autofocus issue.
Right. Thank you. Thank you, Gomati. The another question is, do you have a location in United States? Yes, we do. We are based out of San Jose, California. So if you want to hit us up over there, I'm always game for a cup of coffee. Yeah. So other question is post deduction. Sharath, this is for you. Post deduction and face recognition in-house. Will you prefer stereo cameras or several synced cameras in a multimodal algorithm?
Sure, Alphonse. So in case of post detection, we really don't need stereo cameras. In case of face, we have developed anti-spoofing algorithms. We have our own IP in that area where we have used both 2D and stereo camera to improve our accuracy in case of face. Otherwise, there is no particular need for a stereo camera in these two solutions.
All right, thank you,
The next question is, what techniques do we use for syncing two cameras connected for capturing data? It depends on the type of sensor you are going to use. Generally, global shutter camera comes with a trigger input. So you can obviously use trigger input in the global shutter camera. In case of rolling shutter, there are some ups and downs in the rolling shutter cameras. The trigger input may not be good enough for synchronizing multiple cameras. So there are several ways to do the synchronization. One of the ways is to do ISP synchronization. That's what we do with our multi-camera. The ISP in turn will take care of the synchronization. One other thing is you may have to make sure to set the exposure time to manual, and all the cameras should be in the manual mode with the same exposure time, trigger everything at the same time.
Thank you, Gomati. We have one more question. Is there any camera you recommend to deduct color in diamonds? Gomati, a question for you. Let me repeat it. Is there any camera you recommend to deduct color in diamonds?
Not a particular camera for color diamond. So we may have to look at some of the sample images of it. We will have to try out few cameras to see how exactly to reproduce the colors. So one thing is for the perfect color reproduction, we always prefer manual RGB gain control. So with that, we can make sure we are able to reproduce white as white, gray as gray, blue as blue. So once we are able to do that, then use that settings for capturing any object. It is not specifically for the diamonds, but any object. Go with the manual gain control. Make sure you are able to get white as white first.
So one other question, Sharad, this is for you. How do you deal with untrained products that come up in the field of view?
Generally, how it's done in AI solutions is we keep learning things from the field on the cloud, and we keep retraining our models, and we check for improvement in accuracy and redeploy them on the edge. So we generally have an application pipeline where an edge device is connected to the cloud. So the edge device keeps learning from the environment, retrains itself on the cloud, and gets redeployed, and that's how we attack such problems.
Thank you, Sharad. So one of the questions you have is, do you have any experience with the Depth AI OAK1 and OAK-D cameras? And if so, what has been your experience for POC development? Well, personally, I haven't worked on OAK1 and OAK-D, but I do know some of my engineers have bought it and they've been working on it. My only suggestion here would be when you're picking up a camera for your POC, always think about choosing a camera which, if you can use the same camera when the solution is production ready. So you build this is one of the pitfalls which Maha was talking about. When you choose your camera, make sure you choose a camera which can be production ready. OAK1, for all its hype which we have right now, we are not exactly sure how much useful will it be for it to be production ready if you let's say you want to get your product into the mainstream in the next 1 year. So when OAK1 and OAK-D is good for POCs, if you want to convert that POC into a product, and if you don't want to spend too much time making some solution production ready, I suggest you look at a camera which is already, on production. So that being said, let me just go down. I think I've asked.
So what are the global shutter cameras that can be connected with x86 platform? We have a C3 24 CUG, that's a 2 megapixel color global shutter camera. We have C3 20 CUG, that's a full HD monochrome camera. We also have a couple of 720p cameras. So we can send you the product links or the email.
One other question for you. I am looking out for a product to identify a particular barcode or QR code from a label and capture a video of the activities along with the barcode and save the video with the barcode as the name of the file. Can you suggest suitable cameras?
Maybe some more details would help. So I would probably recommend a simple full HD USB camera with a Raspberry Pi can do that work. I would recommend C3 Cam CU55 probably. But if you can give us more details about when you are going to do that, is it while in the moment, or it is the barcode, or the system is going to be stationary? Those are something we need to consider before using this camera.
All right, thank you, Gomati. Sharath, the question for you is application like smart surveillance cameras are supposed to be installed in an open environment. How do you deal with fogging during winter? Like any anti-fog, how do you manage? I think it's talking about the problem of occlusion here.
We generally use IP67 rated cameras, which are tested in all weathers. Yeah, generally sometimes there are water droplets on the lens, etc., for which we are still doing our R&D in developing algorithms to detect those things, so that we can send someone to clean up such things. So otherwise, most of the cameras we deploy outdoors are IP67 rated.
All right. So there's one other question: said, do you guys have any experience with photometric stereo? Well, the stereo experts are not currently in the call over here, John. So I'll get the team connect you with a stereo expert post this conversation. So for the final question, Sharath, the question to you: what are your thoughts of AI on Android?
Okay. So, like I previously explained, TF Lite is the option for Android, and as I explained during my slides, so TF Lite is mainly for GPUs such as Mali, and Qualcomm has tools for performing TF Lite optimization for their process. So TF Lite is the way to go for AI development on Android.
Thank you, Sharath. And I think that brings us to the end of this engaging Q&A. If there are no more questions, gentlemen and ladies, thank you so much for being a part of this webinar. We had so much fun interacting with all of you guys, and those were a lot of interesting questions. We would be sending across a recording of this webinar along with a PDF of this presentation across in the coming week, and looking forward to do this webinar series along with you. This is the Visaya Labs and Econ team signing off. Thank you all and have a great day.